All right, happy Friday. A lovely, cool, rainy weekend ahead, apparently. I hate when it rains on the weekend. It's always a bummer. So don't forget, Sunday is Mother's Day. Thank you, Jaden. You didn't forget. Everybody else did. Nope. So don't forget about that day. Any special mom, really. Although I told Mr. Kane that I don't need anything for Mother's Day. But we have a softball tournament, so that takes precedence. And it's his birthday on Mother's Day. So who gets the day? Him, me? I don't know. It's his birthday. You think so? Okay, I'll go with that. So we are going to review for your series test on Monday. I have a couple of questions from the review worksheet from yesterday that I wanted to look at and go over with you. And then there's a second series review worksheet, just again to prepare you for Monday's series test. And then on Tuesday, we will continue with the non-algebraic ending of Algebra 2, and we'll start looking at permutations and combinations, the counting principle, probability, and all those types of concepts are on the SATs and the ACTs, and like you're going to see those things in different types of aspects depending on where you major in. There's a lot of probability involved in various outside of math applications as well. So we'll go over some probability and statistics to kind of wrap up the last 3 weeks of the school year. Next week is the last full week of the school year. So if you want to look at your review worksheet, I want to first start off with the partial sums problem. So this is the review worksheet homework from yesterday. This was number one, review worksheet number 1. And number 8 from the review worksheet and 9, we're asking you to find and graph the first 6 partial sums. Now, remember, it is asking for a partial sum, which means it's not asking for the values of the series, but a series is adding terms together. So the first sum is just the first term of 1/3. But then the second sum, S2, means really you're adding the first 2 terms together. You're taking the sum of the first 2 terms. That's what S2 is asking for. It doesn't say A sub 2. It's saying the sum. That's what S represents. So we're finding the sum of the first 2 terms, which means I need to add a 1/3 and a 6 together. That does not make 1/9. You have to have common denominators to add. So 1/3 is really 2/6. And if I add them together, I get 3/6 or 1/2. So then to find the sum of the first 3 terms, you would take the first 2 sums, which is 1/2, and add that to a 12th. So you're taking the 2 sums, the 2 values you already added together, and add that then to the 3rd value, or you're finding the sum of the first 3 terms. What is 1/2 and 1/12? Well, 1/2 is 6/12, and if you take 6/12 and 1/12, you get, Ava, 7/12. So again, you do this as last time because it asked for 4. So you want to find the sum of the first 4 terms. Well, 7/12 was the sum of the first 3, and then you're adding 1/24 to that. Getting a common denominator of 24 means I would have to have 14 multiplying the top and bottom by 2, and that gives me 15/24. So those are the sums. You were then asked to graph it and then find the sum. So graphing it, make sure you label a couple of values. This graph is not labeled. So label the axis with a couple of X values, label the Y axis with some Y values. These are small numbers. So I'm going to make this one a half. I'll just count by halves here and just go up to 2. So my first point is at 1/3. My second sum is at a half. And then 7/12 is a little above a half. 15/24. So that's what my partial sums will look like. And it definitely appears that there is a sum because these numbers are really close together. And you can see that it's curving and eventually it's not really going to go any higher. But by looking at the partial sums, you can say that there is a sum, but you can't really estimate what that value is without actually calculating the sum. When it's an infinite series, what's the formula for an infinite series? So what is the formula for the sum of an infinite series? Jaden? Yeah. So because you can't determine the actual sum by looking at those fractional values, you can calculate the sum by using the formula for the sum. So we're taking the first term. She said, I missed my little one here. So the first term is 1/3. And then Jaden, what are you doing to get from 1/3 to 1/6, 1/6 to 1/12, 1/12 to 1/24? Yeah, you're multiplying by a half. So I would have 1/3 and then 1 minus a half. So my sum is 1/3 over a half. And I know when I'm dividing, I'm really multiplying by the reciprocal. So the sum is equal to 2/3. So if you looked at the answer key and you were like, 2/3, where the heck did that come from? I'm not sure, but I'll still write it as the answer. The sum is 2/3 because of the formula for the sum of an infinite series. Sometimes the partial sums aren't going to give you the actual sum of the series. Alyssa. Sure. Are there questions on number 8, Ava?
I thought you added the like 1/3, 1/2, 7/12. When do you ever add those? Like,
That is what these are. Like these numbers are added together. So like the fourth sum is taking all 3 of those and adding them together. Like this one. You would do that for that, yes. Or you could, because that's giving you an end number. So like you know where it ends. But if you don't know where it's ending and it's infinite, then you need to use the formula. Other questions? All right, Alyssa, you said 11, right? Yeah. Okay, so after you get past number 9, the next problems on here started a cumulative review. And the 10 and 11 here wanted you to multiply or divide. And in order to multiply or divide, the first thing that you need to do is factor. So the problem must be in factored form in order to actually multiply and divide and simplify. So if you look at this first problem, actually second problem, number 11, second of the group, Gabby, so how would you factor the left fraction?
So the first one is
Yeah, so you're dealing with a -20, 10 and -2 make 8. So a +10 and a -2. That's just regular AC factoring. And then how about the denominator, Gabby?
I pull out the GCF 5x².
Yeah, that one is GCF. There's two terms. They have something in common. They have a 5 and an x squared. And when you pull that out, Gabby, you have you left with an x plus dead. I'll stop picking them. The next one, you're dividing. And we just said when you divide, you're really multiplying by the reciprocal. Whether it's written as one fraction divided by a fraction underneath, or these two fractions divided listed horizontally. So this becomes multiplication. And then x squared plus 7x minus 18, that product, when you factor it, is going to go in the numerator. So Ella, x squared plus 7x minus 18, how would we factor that? Yeah. So that goes in the numerator now because it becomes multiplication. So a -2 and the 9. And then Ella, x squared plus 9x is currently in the numerator. What would you do to factor that? Take out an x. And you end up with x plus 9. So in order to simplify, things must be in factored form. You must have an exact quantity that's a product. If it's not a product, it cannot cancel. Now everything is a product. Everything's in parentheses being multiplied together. So Brooke, what can we wipe out here? Can you cancel the x minus 2 and the x minus 2? No, trick question. They're both in the numerator, so you can't cancel those. They're being multiplied together. How would you write that, Brooke, if you have an x minus 2 times an x minus 2? Yeah, there are two of them, so I would write it as squared. And then in the denominator, looking, there's a 5x squared and then x, they're being multiplied together. So Brooke, that becomes 5x cubed. X squared and another x makes it x cubed. So factor first before you simplify. Yeah. So number 7 says write the series in sigma notation, and then it of course says show work. We have 3, -6, 12, and then it goes all the way to -1536. So first question, Lacey, is this arithmetic or geometric to go from 3 to -6 to 12? Yeah, this one's geometric. So we need to know that so we can write a formula. If it's geometric, Lacey, what are you multiplying by? -2. So geometric, the formula is the first term times r to the n minus 1. So the first term is 3, r is -2, and then we have n minus 1. If you're writing the series in sigma notation, we need the formula that goes next to the sigma. It starts at the first term by plugging a 1 in, but then we need to know how many terms there are. What number would I plug in to get to that last term of 1536? To find that, we're going to use that last term and set it equal to -1536. So Grace, how would you continue to solve this equation? Because we need n.
I divided 3 from each side. -512.
So -512, and then
And then I wrote it in log form, so it'd be log -2 from -512 equals. And then plug that in my calculator and got n9 equals n minus 1.
excellent. Questions? So a little 10 goes up above, and that represents the number of terms. So to write a series in sigma notation when it's infinite, like number 6, you don't need the number of terms because it goes on forever. So then I would just put a little infinity on the top and all I need is the formula. But when it's finite, you have to make sure you're finding the number of terms. So arithmetic, we would then use the arithmetic formula. Geometric, we're using the geometric formula. Good questions. Any others? Julia. Yeah, so the group of problems in the cumulative review 13, 14, and 15 were from chapter 7, and actually the 2 word problems were as well. Chapter 7 was our logarithmic and exponential equations. So in number 13, this is an exponential equation. We have 9 to the 3x is equal to 27 to the x plus 1. One of the properties of exponents says if you can get the base the same, then you can set the exponents equal to each other. The base would be the 9 and the 27. So if I can get 9 and 27 to be the same base, then we can take the exponents by the property of equality and set those exponents equal. So how can you write 9 and 27 so the base is the same? So I want to change the number 9. Faith, how could we change 9? So not multiply it by 3. 9 is, how else can we write it so that it's an exponent? So 9 is what as an exponent? So yes, it's 3 times 3, but how would you write that as an exponent or power? Yeah, 3 squared. So 9 is 3 squared. And then there's still the exponent of 3x. That was already there, but we're changing the 9 to be 3 squared. Faith, how could you write 27 as an exponent? Yeah, 27 is 3 cubed. But again, there's still that x plus 1. And that x plus 1 is a quantity that's then going to be multiplied by the 3 that we changed the exponent. So the bases are the same. Change the base. 27 is 3 cubed. 9 is 3 squared. And then when you change that, that exponent gets multiplied by the exponent that was already there. So by property of equality, you can set the exponents equal to each other. Distribute the 3 through the quantity on the right, and then you can solve. And you find x is equal to 1. So that's equality of exponents. The one right next to it. This is a log property with an addition sign. So when you're adding logs to condense them, you pull them together by multiplying whatever's after the log. So x plus 6 and x get multiplied together when you condense these logs. So we would have x times x plus 6. You're not adding them. The property of logs is really a multiplication when you're condensing them. So this really says the log base 4 of x squared plus 6x is equal to 2. Jaden, after you condense the log, then what would you do to solve the log? Yeah, so the base, the exponent, is equal to x squared plus 6x. So this equation becomes x squared plus 6x minus 16 is equal to 0. A positive 8 and a negative 2. You can only take the log of positive numbers. That's why the log of the negative number doesn't work. Let me shrink my screen a little bit there. So we will continue to spiral in some of the previous chapters that we have done. If you go to Google Classroom, I think the worksheet for today is posted. or not. Oh, looks like should be posting. So this is series review worksheet number 2. And it is very similar. I did place the 3 formulas at the top of the review worksheet for you, so you have those to kind of refer to. So these will be the 3 formulas for the finite and infinite series. And then at pretty similar. So find the sum, little word problem, write it in sigma notation, get the partial sums. And then the last one says find the sum if it exists. And then on the next page is some more cumulative review problems. You will see some review problems on your test on Monday. And then your next test will continue to do some cumulative review, and you'll have more cumulative review problems on the next test as well. So there's some review problems at the end of this worksheet. To Friday, Monday's test is 55 points. And it's 3 pages. You'll take it in person on paper. Obviously, if you're at home, you'll take it digitally. So you have 20 minutes to work. Please use this time and ask questions, any that you have. I will be around to answer